Topics in post-harvest technology. Ripening, climacteric versus non-climacteric fruit. Before we talk about fruit, let's talk about maturation. Physiological maturity is usually associated with the ability of a plant to flower and set viable seed. In contrast, horticultural maturity is the maturity of a plant part dependent on its use. Any stage of development of the plant may qualify. In this figure, the top part is dealing with normal plant development and growth, and the top line is development from seed germination to death. We have a growth phase followed by maturation, which coincides with physiological maturity and viable seed production. The seed will mature, the fruit will ripen, and this is followed by senescence or aging. Senescence can refer to the fruit tissues dying to release the seeds, or, for an annual, the death of the plant itself. In contrast, with horticultural maturity, any part of the plant can qualify as being mature depending on how we intend to use it. Let's look at this development line up above. It coincides with all these plant parts below. Early on, we have sprouts. Think of broccoli sprouts or alfalfa sprouts, which are recently germinated seedlings. We consume stems and leaves. Think of asparagus, celery, lettuce, and cabbage. We eat inflorescences, such as artichokes, which are flower buds, broccoli, and cauliflower. We'll consume partially developed fruits. These are immature fruits and are represented by vegetables such as cucumber, green or snap beans, okra, and sweet corn. We eat fully developed fruits such as apples, pears, citrus, and tomatoes. We utilize roots and tubers such as carrot, onion, and potato. And lastly, notice that it coincides with senescence. We eat dry seeds such as red kidney, pinto, and lima beans. These seeds are associated with senescence as the pods that have contained them have died and dried out before releasing the seeds. For annual plants, they too will die at the end of this cycle. Perennials, in contrast, follow this cycle but don't die after fruiting and live year to year to produce flowers, fruit, and seeds. What are the attributes of ripening? Ripening is an enzymatically controlled sequence of events. It is hormonally regulated and it requires respiratory energy. What is the respiratory climacteric? The climacteric was discovered in 1925 by the scientist Kidden West. It's defined as a characteristic rise in respiration, that is CO2 production, during ripening. It is associated with quick ripening, and fruit are classified as being climacteric or non-climacteric. Climacteric fruit produce elevated amounts of ethylene, and they produce this autocatalytically, which means that the ethylene that's produced in the tissues triggers more ethylene production. This ethylene production triggers rapid ripening. With climacteric fruit, ripening is able to occur off the tree, bush, or vine. With climacteric fruit, exogenous ethylene will trigger ripening prematurely. Now, exogenous means ethylene occurring outside the tissues, so externally applied ethylene. If it were ethylene produced by the tissues themselves, it would be referred to as endogenously produced ethylene. What are some climacteric fruit? Well, we have muskmelons, also known as cantaloupes, tomatoes, apples, avocados, and banana. Non-climacteric fruit do not produce large amounts of ethylene during ripening, and ripening is usually slower compared to climacteric fruit. With non-climacteric fruit, ripening does not occur off the tree, bush, or vine. Exposure to exogenous ethylene increases respiration, but only during exposure, and it does not trigger autocatalytic production of ethylene. For non-climacteric fruit, exposure to ethylene may result in degradation in tissue quality. Some non-climacteric fruit are citrus fruits, olives, grapes, blackberries, and strawberries. In this figure, relative rates of change or production are on the y-axis. Different phases of growth are along the bottom of the figure on the x-axis. We see cell division followed by cell enlargement, ripening, and senescence. Notice too the overlapping growth phase followed by the maturation phase. The dotted line is for non-climacteric fruit. The solid line is for climacteric fruit. When you observe the growth curves for climacteric and non-climacteric fruit, they are essentially the same. However, with respiration, the rate is continually decreasing for non-climacteric fruit from pollination to the time the fruit is senescing. In contrast, with climacteric fruit, just before ripening, ethylene production begins to increase, which then triggers increased respiration, the climacteric. Ethylene production increases until its precursor, ACC, begins to deplete, at which time ethylene production decreases. You'll notice that the climacteric, that is, elevated CO2 production, mirrors ethylene production. Please remember that experimentation has proven that ethylene triggers the climacteric in climacteric fruit. This is a table showing climacteric fruits on the left and non-climacteric fruits on the right. We have quite a few climacteric fruits, but we also have quite a few non-climacteric fruits. Summary points. Many specialty crops are used at horticultural maturity, that is, at a maturity depending on use. Any stage of development may qualify. The climacteric refers to a transitory increase in respiration associated with the ripening of some fruits. It is triggered by ethylene. Climacteric fruit are able to ripen off the tree, vine, or bush, and usually ripen fairly rapidly. They may be induced to ripen by exogenously applying ethylene. Non-climacteric fruit do not ripen off the tree, vine, or bush, and usually ripen fairly slowly. Exposure to ethylene, a senescent hormone, may cause a decrease in quality of non-climacteric fruits.